All right, so I should be live now and audible for anyone who's listening. I'll just double check on my stream to make sure that I'm audible. There's a little bit of an input lag, so I do have to wait a few seconds until I get I got the confirmation. All right, last time, yesterday where we left off was we were having issues while training our LSTM model. And just to go over the agenda real quick, we're on day 3, only 97 days to go, which is a little over 3 months. But, gotta take things step by step, and let's focus on what we're doing just today and forget about the other 97 days, which makes it much easier. So, day 3, deploy a deep learning model using Streamlit. And I believe we were training the LSTM model, which is a recurrent neural network. We have not created the UI, so we have to do that today and deploy the trained model as a REST service if we can get the model to be trained. So I think the error we were having yesterday was something to do with change the lights real quick. For some reason, my lights are flickering. And it kind of makes me concerned, because if the power is fluctuating, then my PC might burst any second, which is a problem. All right, so let's see. Here we are in Jupyter, in my Docker container. I deployed this earlier before the stream started. So I built the imports, downloaded datasets, and downloaded the dataset for the LSTM model from the internet, from TensorFlow datasets. Ran through the model, compiled it, and when we tried to train it, right before we tried to train it, we tried to set the memory growth so that we don't have any problems while training. But for some reason, we can't change the memory growth during runtime, which makes sense, I mean, if you really think about it. Well, okay, let's try running this again. And what we'll do is debug this for about approximately, like, let's say 10-15 minutes. And then I think after that, if I don't have any progress on this issue, what I'm going to do is just pick a different model and then try to train that instead. Because I think this has to do with the model itself and not really the software. Okay, this is my code. Well, this has a -1 review. Let's not check that. This before your code. He's configuring stuff. Configure GPU, allow growth. Okay, we could try this. Wait, this is V1. Does that mean he's using TensorFlow version 1? Which TensorFlow version is he using? When was this released? 4 months ago? It should be fine. 4 months ago, I think TensorFlow 2.0 was pretty much the standard. Alright, let's run this. See if it gives us any errors. Nope. Okay. That did not work. Your Kuden version is too old. Had the exact same error. I don't think that's the issue, because pretty sure that the Docker container is from TensorFlow itself, so it should have all of the packages necessary. Docker image ls. You can see here that this is an image from TensorFlow. All right, let's do this. We'll download another image from TensorFlow with a more stable version. TensorFlow. And we'll download a Jupyter version. No, not here. here we go. We need to go to the Docker hub. And let's go to TensorFlow. Then we can pick out the things we want. Let's see, we'll go to TensorFlow, and then we need to choose something that will work on our computer. So we can have latest GPU and Jupyter. This means that it uses the GPU and it uses Jupyter. But latest always has a couple of issues, so we want to go with something that's more stable. It's 2.5, 2.5. We can go with 2.4.1. I believe this is, it's the same, 2.4.1. I don't know if that's the most stable release. Okay, the RC versions, I believe that 2.5 should be out. Custom op, we don't want to go to custom op. We could go with just the latest. There's no 2.5 Jupyter and GPU. Oh, wait, there it is. All right, let's try doing this. Where did I go? 2.5 GPU Jupyter. Let's just check. Okay, it uses CUDA 8.1. Which is good. I mean, that should be the latest CUDA out there. Okay, let's copy the command and run it. Docker pull, and we'll go copy paste this. So these sizes become really large. Like you can see here that the 2.4 version is approximately 6 gigabytes in size. So you don't want to like store a bunch of different Docker containers that just eat up your memory. So be very careful. You want to release them as soon as you're no longer needing them, so it doesn't like eat up all of your storage. I think I should have a decent amount of storage left, so I'm not gonna really worry about deleting the previous versions. Let's just make sure that this works first. This might take some time. In the meantime, we can continue with the Streamlit app. So here in our LSTM folder, we'll create the Streamlit app. Alright, I think our Streamlit app will be a little more different because it shouldn't be that much different. I mean, we're entering a text and we're predicting the sentiment, which is either like positive or negative based on 0 and 1. So I don't think the application code should matter. Should be that different. So we can just use this for now. Let's see, where does their application code start from? Right here. Okay. So LSTM, we'll create a new file. We'll call it app.py. That was slow. Import OS, import as MP, import pandas as PD, import pickle, import tensor, STF, from TensorFlow, .char rest. I'm not sure if we need the tokenizer or the pad sequences, so let's skip out on that and let's just load in models. From this is import. And from TensorFlow, keras dot models, we need to import model from JSON. This is so we can load in our train model at the end. Import Streamlit. import regular expressions, RE, and set os.environment. I'm not too sure what this is doing here, but let's just include it for the sake of including it. I think this is just indicating where the TensorFlow logs are. So we don't have the tokenizer. We don't have the model.json yet. So we'll skip all of this loading model part. We're going to skip the prediction part as well because we don't have the model. We're going to write in the template. So let's start with our the UI. Streamlit.title sentiment analysis LSTM model. HTML template. It's going to be empty strings. Streamlit.markdown, and then put in our HTML template here. We'll get the input from the user, review, enter the review, prediction, make a variable for our answer, and if the Streamlit button is pressed, and we'll call this button predict sentiment. What we want to do is send the prediction. Of course, get the prediction from our method. But we don't have the method written in yet, so we're just gonna skip this for now. And then we'll do streamlit.success. The sentiment predicted by the model is, and we use format to display our output. Format, and then we'll write in the prediction. We'll get this running. Okay, cool. So let's go back to our Jupyter and see what happened here. What was I waiting for? Oh, the Docker container, of course, right? It's almost done. It's on the last extraction. No, it has to extract all of this. It's almost done, though. All right, I mean, I guess we can, let's see, run the Streamlit application. This is running Jupyter, this is running Docker, and get another tab to run Streamlit. We need to cd into Streamlit deployment and cd into LSTM. Okay, now we can do Streamlit run app.py. Oh man, okay, so yeah, this is gonna run into issues with the TensorFlow code. We might have to run the Streamlit application within the Docker container. This complicates things. Okay, let's run this Docker container first. What is this called? Here we go. It's called this. Let's use the image ID to open it up. And then we'll paste in our image ID here. Okay, let's Right, so I'm still running this Jupyter Notebook. I need to close this. Yes, end it. Okay. Now we can run the other container. And let's go to this location. All right, so Streamlit deployment, LSTM model, and let's run this. See how it is. This might take a couple of minutes to perform. In the meantime, we're going to go to the terminal and try to what's that going to do? Try to deploy the Streamlit application. Right, so let's see. Why isn't it showing? Why isn't it showing my folder here? CD TensorFlow? Only directory available is TensorFlow data sets. And it contains the model. Why am I not able to access this folder? I'm not able to access any of this. It just doesn't show up. It's the annoying part. All right, let's see what happened here. Okay, it's up till here. I believe we're gonna have the same error. Oh my gosh, we're not. That's amazing. Awesome. So we solved this. And you know, in fact, what we could do is also I'm gonna go help the other guys who are having the similar issues with the previous error. I need to let them know that this new Kudun version with TensorFlow 2.5 works. I forgot what the issue was called, but I'll do that later. Actually, I could do it right now. What was the error called? Check our history. Limit usage. It was called this. Unknown, blah, 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 blah. So let's go to the GitHub issue. Was it this one? I believe so. And the issue is open, so yeah, I'm going to suggest my answer here. What was the Kudun version again? Let's check the Docker hub. Let's go to tags. Let's see. Kudun version 8.1.0. the 1.0. The let's see, what's my CUDA version? CUDA 11.2. Let's just format this nicely. Make it look readable. TensorFlow 2.4, TensorFlow version. Alright. Preview. I got a similar issue with TensorFlow 2.4.1. What was fixed after I upgraded to TensorFlow 2.5 with CUDA and CUDA. Okay. Cool. Gotta always help out your fellow researchers and fellow software engineers while you're at it. Let's see, what's the loss accuracy? Accuracy 87, not bad. It's getting better. Loss is decreasing, slower than before, but still. Oh, it didn't actually decrease a step, but sometimes it takes. Oh, it's epoch 10, so this should be our last epoch. We're gonna end up with accuracy as 87.68. It's not bad. Alright, we'll keep this for now. I mean, we shouldn't have any issues. And let's save our model using the same process that was shown in the book, so we don't have any issues when loading up the model. Alright, let's see here. Did we ever display the model? We never did, but we can do that right now. Model.summary will display a nice graphic of how, the different layers that you're using. So we have a text vectorizer, goes into embedding, bidirectional, dense, and then dense again. Before we do this, actually, let's predict using the model that we just trained to make sure that it works. TensorFlow sample analysis, and we're using the RNN. All right, so we can print the test loss and accuracy. Let's do that. Test underscore loss. That's too many S's. Test underscore accuracy. Model dot value. Test underscore data set. And then we're going to print our test loss. And we're going to print our test accuracy. I think this step is just testing. And then we'll display our nice figures using matplotlib. You could also use TensorBoard, but the code for this is much easier right now, because otherwise we'd have to save our logs and open it up with TensorBoard. You have to write the TensorBoard code to open it up. We're going to bypass that by just using matplotlib. 2, 1, So unlike, oh man, it's tricky trying to talk and write at the same time. Unlike matplotlib with TensorBoard, everything's done for you, so you don't have to write all of this whack code. And it has a lot of additional features as well. So if you're doing some sort of big project, that's not how you spell graphs. So we're printing the accuracy and the loss graph. Let's see, node. Wow, there should be a none. Beautiful. There we go. We have our accuracy versus loss. Validation accuracy. Same thing here. Training versus test. Validation. And let's use the model to predict. Call this prediction. PREDIC. That's not right. So we'll provide the sample text. And I'm going to copy paste this. There's no reason going through the pain of actually rewriting this. It's not going to provide us any beneficial knowledge. Prediction says model.predict, and then we're going to convert this to a NumPy array. And let's see what our answer will show up as. I think what we do is just display predictions. And we got a number, a float number, but still a number. Pretty good. Wait, hold up. Was this before? Where was that code? Running the predictions. So if the predictions is greater than 0.0, it is positive. Else it's negative. So it's clearly greater than 0.0, which is a positive number. So this means it's a very positive connotation. Let's change the words here and make it like a negative color. I would not recommend this movie. We're really bad. Awesome. You can see here it has a -2, which means if it's less than 0, it is negative. And we can do that with a simple if statement. If predictions is greater than 0.0, we'll print positive. Else we will print negative. And if only I could spell things correctly. And yep, okay, cool. So here it's extending the model by stacking 2 or more LSTM layers. So it's just adding another layer of LSTM bidirectional. We're going to avoid that. It does increase the accuracy. And validation loss does pretty well. Let's see. It's still 85. It's about the same accuracy as we have right now, so I think we can avoid. It's at 86. What's ours at? Our test accuracy. 86.4. Yeah, it's not that much of a change. So, in fact, it actually does worse. Yeah. So we're gonna keep this. Let's save the model. Yeah, that's a lot of tabs. Okay. Where's the code for saving the model? Let's just check how they predict versus ours. So here it's passing in basically it's a list with a string. For us, it's kind of just like a string. And then we convert it into a NumPy array. What they do is they tokenize it, use a pad sequences, and then they use NumPy argmax. If it's 0, they print negative. They use model.predict, and we pass in the test. This should be, what does this end up being? Just like a regular, I'm not sure what these return. Okay, we'll just have to modify the code when we're loading the model, but that shouldn't be too much of a challenge. So, okay, why are we saving our model? Yeah, we're saving it right here. Okay, with open, do we need to import OS for that? I don't think so. With open, and then we're going to call this token. Oh, we don't have a tokenizer. That's right. We don't need to dump the tokenizer. Instead, we're just going to create the model. Model underscore JSON. Model2 underscore JSON. We do need to import this though. And then with open, we're going to call this model.json, and then we're going to open it as a write as JS, and then we're going to do js.write model underscore JSON. If we run this right now, it's going to give us an error, and we have to save the weights, of course. Model.save, and then it's going to save it as an h5 file. Model.h5. To JSON, model to JSON. I don't think we have to import that. Okay, let's just run this. Save or restore weights that is not an instance of TF variable. It's not an instance of a TF variable. I mean, half of software engineering is just figuring out why things just don't want to work and fixing the issues, so it's a very common process. The issue has to do with the text vectorizer, so we'll copy that. Please use TF format to save the model. So I just have to specify the save format as TF format. TF, is that what I have to do? It's not that thing is called save format. All right, I guess that saved the model, but I'm not sure in what form. So we'll check that. Yeah, it did save it in H5, which is good. That's what we want. We have an index, data, we have checkpoints out here. All right, cool. Let's try to get the app working now then. Oh, and we have to load this, run this app. This is gonna be annoying. You know what I'm gonna do? I'm actually gonna open up a Hugging Face Docker container. Docker ls, docker image ls. Open up the Hugging Face. So to open that up, I don't need any of this. I need to figure out what the print directory is. Let's go to my GitHub page, text summarizer. Let's go to model. Is this what it is? I wrote TF here. Ah, I think I forgot to update the README. We'll figure it out. It's okay. VMware GPUs all. Let's just guess it as root. Hugging transformers, TensorFlow GPU. LS, it's transformers. So that's what we need to call it. So we need to stop this Docker container. Docker stop, and then we're gonna stop. I think it's Docker container stop. And let's stop this container. Right, okay, now we can deploy this again, but we need to call this transformers. So we can import our files. All right, we have all the files in here now. Where is it? Where are the things that we need? Okay, this is not good. I think I got the application wrong again. So I think we have to import it to TMP. Oh man, what the heck's going on? Current working directory, we need to go to /tmp. It should display it here. All right, I think, yeah, we got it. Streamlit deployment, cd LSTM, and then we'll run our Streamlit application. Just checking if Streamlit's installed. Okay. Streamlit run app.py. Oh, I need to open up the port. Okay, let's just export. I still didn't open up the port, so this might result in issues that I have to solve again. So we have to use the -p to expose the port, which is 8501 when creating the container. Otherwise, it's just not going to work. So let's rerun the Docker container. But this time, let's expose the port. So we need to do -p and then port, what was it, 8501? Alright, so let's cd back and then cd into temp and then cd streamlit LSTM, and then we can hit install Streamlit. It's gonna take a little bit of time. Get some water in the meantime. Okay, we're gonna export these variables. Okay, this works. Cool. So we have it running. All right, let's go back and complete this, I guess. Well, how are we doing on time? We're still under an hour, so I think we can finish all of this today. Thankfully, we got the bug solved at the beginning in under like 15 minutes, which was actually kind of surprising. I thought I wouldn't be able to complete it. But thankfully that did happen, and we're on our way. All right. So we have to load the model in Streamlit. Okay, so we don't need the pickle. I mean, we don't need the tokenizer, but we need to open the JSON model. Let's go model.json. But we don't have a model.json, do we? No. Can we just LSTM model from JSON, loader model? How did we save the model here? Where is it? Model to JSON, and then we should have written the model as a model.json file. Oh, it's right here. Okay, cool. So we do have it. All right, let's open up the JSON file. In read mode. Loaded model. I'm going to use JSON.file. What? JSON file dot. Oh my gosh. Read. And then we can close it. Now from model from JSON? Where is this coming from? Oh, it's we need to import all of this. So we need to import from TensorFlow dot curious.models, import model from JSON. Wait a second, I didn't even import Streamlit here. Oh shoot, I'm editing the wrong file. Okay, that makes more sense. Let's go back to this. And there we go. Whoopsie daisies. Let's change back everything that we change the state here. I mean, not that this file even matters, it's half complete. Okay. But I'll honestly get rid of this file. And I think I'll do that. Because we did use the notebook to save the model. Okay. So LSTM model from JSON. Loaded model JSON. And then we're going to use LSTM model.load weights. And then load it into H5. So we have all the imports, I believe. Except the tokenizer and the path sequences, which we don't really need. And the pickle, actually, which we still don't need. Okay, and we're gonna call this loading in model. And now we're going to write our method for prediction. So let's write sentiment prediction, review, sentiment We're going to keep that as an empty array. Input review is equal to review. And then we're going to pre-process lowercase and add a little bit of regex. I don't think it matters too much because in our model we have the vectorizer, so token text vectorizer. So either way, our inputs are going to be processed in the model. So we don't need to tokenize, we don't need the path sequences. All we need to do is predict. So sentiment is equal to LSTM model dot predict. And then we need to pass in the numpy array of input review. And then we'll return sentiment. Oh, we could actually process this a little bit more. So if sentiment is greater than 0.0, we'll return, or prediction is equal to, what is it, positive? And otherwise, it will be negative. And we'll return prediction. Boom, boom, boom. All right, let's rerun our Streamlit app. Okay, this just means that TensorFlow is loading and it's going to use the GPU. So let's not worry too much about that. Actually, I guess we do need to worry a lot about that because TensorFlow is now loading properly. Oh no, it's not. It's not that. Vocabulary size. We actually have an error in the code. Vocabulary size. Keyword. Where is this happening? Just a little bit. So vocabulary size is not being specified. Is that the issue here? Vocabulary size. Where did I set vocabulary size as a constant? I do here. Coder should be embedded. So you just copy paste the constant variables. rerun. Oh, I didn't even know that was possible. That's so convenient. I guess that's a nice feature for Streamlit. Provided a sample text like this. Provided it as just a string. So here we're providing as a list. Provided as just a string. And let's do none of this pre-processing. Same error. Is this actually rerunning? It is. Oh, we do make a list out of it at the end, actually. Where is it? Empire A, and then it's a list. So I think what the error is actually right now is the fact that has to do with the text vectorizer. Yep, right here. Okay, so is it this? Get vocabulary size. Get vocabulary. What if we define our encoder here? Train data set is not defined. We don't really need a train data set. Line 15. Line 15. Ah, shoot. I don't want to load the data set though. That defeats the purpose of this application. What if we just don't adapt it? Does that make a difference? Yeah. So this encoder layer is causing a lot of problems. And I think that's why in this book they pickled the tokenizer. And they didn't even include it as a layer in the let's see, sequential. Yeah, they didn't add the tokenizer. The tokenizer, they just did it before. They separated the tokenizer from the actual model. So I guess what we could do, possibly tomorrow, is retrain this model, but remove the encoder, keep it outside, encode all of the values before we actually train the model, and then pass it to the model after encoding the input. So I guess during our train function, we have to separately tokenize everything. How do they train here? Train test split, and they use fit. I guess the tokenizer is just completely different. It's like completely isolated. Oh, they do it here. So they use X, and then they use the X for the train test split. So okay, cool. Yeah, so we're gonna have to isolate the encoder, and then probably save the encoder as a pickle file, and then load in the encoder as a pickle, and then encode the text before running it onto our model, because I think that's what the issue is with the type error at the moment. Vocabulary size. It has to do with the encoder. All right, so I think it's because the encoder isn't actually being saved when we save the model for some reason. Let's search through Google just a little bit more. Order model. Vocabulary size, okay. But I don't think there's anything on the internet for us. Let's try to understand what this error actually is, though. So too much code to actually go over. Where does this guy use it? Compile. Where is his model, though? Oh, this is his model. $68 thumbs up, so this literally has to work for... Let's see, when we compile our model, which is up here. So should we not specify the parameters as positional parameters? 0. This is a TensorFlow layer, though. That's a problem. All right. We'll solve this issue tomorrow. We're close. We're almost done. So, as I predicted, I mean, got most of it done actually. We trained the model. We created the UI. Just need to deploy the model as a REST service. It's been moved to tomorrow. Save that. That's our goal for tomorrow. And suppose if we do finish it, which I want to very quickly, in fact, I want to move on to reading chapter 4. So I might do the reading off camera just because it's a little boring to do on camera. Okay, so read chapter 4, machine learning deployment using Docker. So we're going to learn how to deploy the model using Docker. Right now we've been using Docker to, well, kind of just use the correct version of the software. But I'm assuming in chapter 4, they're going to teach us how to containerize the entire model and deploy that container onto a virtual machine or a cloud service where it can be run on the cloud or any other computer and deployed onto the internet. Right now, we're running everything on the local machine, my local PC. So we want to learn how to deploy Docker and also learn about Kubernetes and how that works into serving models. I think that's chapter 5. Cool, we're getting there. Progress. So that's day 4, and then we'll make a day 5 goal, which will be the Kubernetes. Did I close the book? I did close the book. Is there any code examples in this? No, it's mostly just... Oh, there is. If we're going to create a GCP and then go through all of that. Let's see if there's a code example for Docker. I think there is. So after tomorrow's Streamlit, we're going to deploy the Docker container. So we're going to call this deploy ML. I think first we're probably going to deploy an ML model. I'll just call this deploy using Docker for now and leave this empty. Awesome. All right, so tomorrow's goal, change this up, have the encoder on the outside. Hopefully that fixes the issue with the production application. And we'll be on our way. All right, thanks for watching.